In this video, we are going to learn how to draw diagrams to represent single covalent bonds. Later on, we'll learn how to draw things called double and triple covalent bonds, but for your purposes now, what we're drawing is how we represent a covalent bond. And we're going to use some background information because, first of all, as we're drawing these pictures, I want you to be thinking about how they're different from the pictures of ionic bonds that we already learned how to draw. And then I also want you to think a little bit about the dot diagrams that we learned how to make quite a while ago, because this concept really builds off of your ability to draw dot diagrams. And I'll come back to that in a moment. Before we get started on drawing these, I want you to highlight or underline a couple of important pieces of background information. So hopefully this is not new to you, but just a reminder. First of all, when nonmetals bond or connect to each other, they share their valence electrons, right? Which is what we're really going to be trying to show here, is how they share electrons. And that's different from ionic compounds, where the electron gets completely transferred off of the metal and onto the nonmetal, okay? The other thing that you really need to remember, and this is going to really help you as you start to draw pictures, is that the goal for every atom is to have 8 electrons around it. I may have mentioned that this is called the octet rule. Octo is the prefix for 8. The name of the rule doesn't matter. But every atom to have a full outermost shell wants to have 8 electrons around it. So in a dot diagram, that would mean, that's why we always try to put 8 dots around the atoms in the ionic compounds for the nonmetals. Okay, the one exception to that rule, like is always the exception to the rule, is hydrogen. It's the little baby of the periodic table, and it's only big enough to hold 2 electrons. So every other atom is full when it has 8 electrons around it. In other words, 8 electrons in its outermost shell, and for hydrogen, it's full with just 2 electrons in its outermost shell. Okay, and so for that reason, because hydrogen's so little, hydrogen can only form a single bond. Other atoms can form up to 4 bonds, 4 connections between them, but for this worksheet, we're just going to deal all with single bonds, and the next worksheet we'll get to double and triple bonds. So the rest of this is sort of instructions on how you're going to draw these pictures, so I think it's easier if I demonstrate that. And I'm going to switch pens here. So you can pick up your pencil, and it really is best to use pencil. If you're not using pencil, you're going to want to sort of do a rough draft of these drawings before putting anything into the final answer box. This is something that takes a while to get the hang of, so you're going to need to kind of be gritty here and stick with this and practice a lot when we get to class. But for now, please make sure whatever I write down, you're also writing down. So when we, for example, decide that we're going to draw, a picture of nitrogen triiodide. I've shown you here that that means you have 1 nitrogen and 3 iodines. That's the compound that we're trying to draw. And nitrogen and iodine are both nonmetals, which is why this is a covalent compound, and so we can't draw it in the same way as we did with our ionic compounds, where we used brackets and plus and minus numbers and all that. So on the previous page in this packet and in the activity that we probably already did in class, there were some steps that sort of walked you through steps for drawing these so-called Lewis structures, or these pictures of covalent compounds. And the first step always, and some people try to skip this step, and it's not a step you can skip, is to add up the number of valence electrons that you have to work with. And so the way you do this is you look up what column nitrogen is in. And if you look on your periodic table, it's in the 5th column. Please make sure you can figure out how to do that. If not, you're going to need to ask me that in class. And then we're going to look up iodine, and iodine is in the 7th column, but we need to take into account that there are actually 3 of these iodines. So our iodines give us each 7 electrons. So we have a total of the 5 electrons from the nitrogen, and then 7 electrons from each of the 3 iodines. Right? And so you can multiply or just do a bunch of addition problems, but when you add this up, you get that you have 27 electrons to work with. And this is a really important number that you're going to need to focus on as you make your drawing, because that means that you have to have 26 electrons represented in your final answer. You can't have even one more, and you can't have even one less. It's got to be exactly 27 electrons. bonds. Okay? So the next rule is that we're going to draw our skeleton structure, meaning we're going to connect our central atom. And we talked in the previous worksheet about how our central atom is the atom that there's only one of. So in this case, that would be nitrogen. There's one nitrogen while there's 3 iodines. So nitrogen's our central atom, and then we're going to connect the other atoms, each with a single bond. And bonds, connections between atoms, are represented by a single line, but that single line represents 2 electrons, shared electrons, one coming from each of the atoms. So if I do that, and I'm going to kind of draw this over here where I have more space. If you're in pencil, you could do this in your final answer box. If you're in pen, you better do it where I'm doing this. So I'm going to draw nitrogen in the middle, and then I'm going to connect my iodines. 1, 2, 3 iodines. Okay? Now, each one of these lines, this one right here, this one right here, this one right here, each represents 2 electrons, okay? And one of the electrons belong to nitrogen and one of them belong to the connected iodine. And they're sharing those electrons now. That's what makes this a covalent bond, okay? So if each of those lines represents 2 electrons, then that means we've already used up 2, 4, 6. We've used up 6 of our total electrons, right? What do we do with the rest of them? The rest of them, we're going to start placing around each atom except the central atom, okay? Also, if we had hydrogen in this picture, which we don't, we would never add dots to hydrogen, because hydrogen, once it has the bond, that line, that represents 2 electrons, and now hydrogen's shell is full. So never any dots around hydrogens, but I don't have hydrogen. So I'm going to draw my more dots. So I already have these representing 2. So 3, 4, 5, 6, 7, 8. And then these are 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I have now used 24 dots. You'll notice every atom except the central atom now has 8 electrons around it, right? Like if we look at iodine right here, it's got 2 right here, 3, 4, 5, 6, 7, 8. See that? And if our other iodines, if we counted them, would be the same thing, 8 around each. Okay? Now, since I've only used 24 electrons, and I have a total of 26 electrons to use, that means I have 2 more electrons left. So if you have any leftover electrons, once you've put all your bonds, all your lines connecting your atoms, and once you've put up to 8 total electrons around all of your other non-central atoms, then any leftover electrons get placed on the central atom. Okay, so I have 2 leftover electrons, and I put them here. And that, conveniently, works out so that now my nitrogen also has a total of 8 electrons around it, right? Because these 2 would count, then 2 more, then 2 more, and my last 2, that's 8 electrons around the nitrogen. Yeah? So that means that's my final answer. The way to determine if you have finalized your drawing and it's all correct is to ask yourself 2 questions. Okay? First question. Oops. Do I have 8 electrons? You should be writing this down. Sorry. It's hard to read my handwriting. Do I have 8 electrons around each atom? So that's question 1. Okay, we do. And question 2, have I used all available atoms? Oops, excuse me, electrons. Okay, and if you have, that's your final answer. And you can redraw your final answer. Mine's going to look messy no matter what because of this stupid stylus that I'm not good at using. But try to draw it as neatly as you can in the box so that, you know, whoever's grading your test, aka me, can read it. And then you're done and you can move on. Okay, now I think it would be smart if we did one more. And we're going to be strategic about that one. We're going to skip down to question 2. We're going to do this one together because it's got hydrogen in it, so it works a little bit differently. But some of the rules are still the same, okay? So the first step is always, like, this is the biggest thing that people forget to do, or they purposely skip it because they think they can, and you can't. You got to count up how many electrons you have to work with. So, right over here for space. Each hydrogen's in the first column, first family of the periodic table. So each of the 2 hydrogens, because I got a 2 here, each of the 2 hydrogens gives me 1 electron. 1 from each of them. If I look up sulfur, which I just have 1 of, it's in the 6th column, 6th family on the periodic table. So it's got 6 valence electrons. And so if I add those all up together, I have a total of 8 electrons. So my final picture must have 8 electrons in it. Okay? My next step, still the same, I'm going to draw my skeleton structure with my central atom in the middle. And my central atom is the one that I only have 1 of, right? So in this case, it would be sulfur. And then I'm going to use these bonds that represent 2 electrons each, 1 belonging to sulfur, 1 belonging to hydrogen. I'm going to draw these bonds connecting them. So that means now that I've used up 2 electrons here and 2 electrons here, so a total of 4 electrons. It also means that this hydrogen is totally full, and so is this one. We never put dots on hydrogens, because once you draw a bond, that's the 2 electrons that fill hydrogen's shell. So that means I have 4 more electrons. And remember, if I have any leftover electrons, which I do because I can't put them around my hydrogens, then I put them on my central atom. So 1, 2, 3, 4. Okay, now I have used a total of 8 electrons, right? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons I've used. Check, that's my first rule. Excuse me, my second rule. And do I have 8 electrons around each atom? Well, I have 8 electrons around sulfur, and then of course my one exception to having 8 electrons around each atom is hydrogen. So my hydrogens don't, but they're not supposed to. So that means that I have my finalized drawing. I'll just redraw it here so it's clear. And I'm good to go. Okay, so you guys have a number of more of these that you're going to do when you get to class. And I encourage you, if it helps you, to see the steps written out, to look back on the previous worksheet where they have all 5 steps written out. And when you get to the bottom of the second page of this worksheet, you're going to have a mix, ionic compounds and covalent. So you're going to have to really think back, or maybe pull out your ionic compounds packet to remember how to draw pictures if you have a metal and a non-metal, because those are the ones with the brackets and the plus and minus charges, so those look different. But for the time being, we'll focus on this the next time you get to class.